today's discussion. So we are discussing on plane space problem, right? And two-dimensional space problem. In the previous class, we have understood what is a two-dimensional space problem and what is a plane space problem. And when we are studying the plane space problem, then we have seen that if an element is subjected to both normal space as well as shear space, and if we take a plane, any plane, inclined in that element, so what will be the state of space on that plane? So we have taken an inclined plane. In the previous class we have concluded here only. So in that inclined plane, we have a normal space sigma n, and we have a shear space, let's say tau. And how these normal space and shear spaces related to the normal space and shear space is sigma x and tau xy or tau yx. Okay, that we have to find out. So considering that, you see, there will be resolution of forces, and in the previous class only I have told you that you will have to resolve the forces in x direction and y direction using fx cos phi, fx sin phi, like that, and then you will be coming up with some equation which will define the stress condition of sigma n and tau. So before doing the resolution, you see, just you notice this one, because we have to relate this a to x. You see, the equation will have terms like dAn and dAx when you resolve the force, because both sigma x into dx, and in the normal plane, the area of the normal plane is dAn, then we have said force is sigma n into dAn. So we need to relate x, dx and dAx. So how it can be related? It's very simple. So what is dAx? So you have seen that this is your dAx, right? And this is your dAy. So if we go for the resolution of the area in cos in the two normal axis system, then what you will get? You will get cos phi. So your cos phi will be equal to dAx by dAn. What does it mean? That means if this area along this plane is dAn, if the area along this plane is dAn, then what will be the component of this dAn along this axis? It will be dAn cos phi, isn't it? It will be dAn cos phi. And what is this? This is actually dAx. So dAn cos phi will be equal to dAx. So that's why cos phi will become equal to dAx by dAn. This relation will be required when we will be resolving the forces. You will see that. So that's why we should first understand this. And then you see, sin phi will be what? So if I resolve the force along the y-axis, then it will be dAy upon dAn. So using that, what you are getting? You are getting dAx equal to dAn cos phi and dAy is equal to dAn sin phi. Correct? So we have changed the area component along the x-axis and y-axis into a term of the area which is of the inclined plane. Okay, so component wise we have just changed. Okay, now why it is being changed, that we will understand in the next step. So now let us start doing the resolution of the force. So you see, so if you multiply the area and all, you will get the force, and then you need to resolve the forces. So let's try resolving the forces, and I will suggest that you also try yourself for resolution of the forces. Then it will be very clear. It is not at all difficult. So you try to resolve the forces along which axis? So sigma n dA. So we will resolve the forces along this axis and along the. So we will resolve the forces along this axis and we will resolve the forces along this axis. Everyone understand? We will resolve the force along this axis and we will resolve the force along this axis. Okay? So how does the coordinate system changes? So you see, coordinate system, I should not say change. So you see, this is your xy plane, original xy plane, right? And there is an inclined plane. Let's say this one is your inclined plane. So this inclined plane is making an angle phi. So along this, you see, this sigma n dAn is active. Correct or not? Sigma n dAn is active, right? And you see the sigma x dAx. So you see, along this plane there will be sigma x dAx will be acting in the normal to this. So you see, along this x, if you take, so there will be a normal component along with this dx will be acting, and along the plane that tau yx will be acting. So if you start resolving the forces, so you check this figure, and if you start resolving these forces along this axis, so sigma n dAn, okay. So let's say this is my positive direction, okay. So what will be the resolution of force? Sigma n dA, the first term will come, and then what will be the other forces coming into picture? Can anyone tell? So what will be the other forces coming into picture? So sigma x dAx cos phi. There will be sigma x dAx. What is sigma x dAx? This is your sigma x dx. Try to understand clearly, okay? Very simple. So sigma x dx, this is the direction of x, this is the direction of y, okay? So if I consider this as x-axis, then in which direction sigma x dx is acting? In this direction. Is it not? Okay? So sigma x dAx is the force which is acting in this direction, right? And what is the component of this sigma x dx along this? Good? Sigma x dx cos phi. This is the direction of sigma n dA. So if this is acting in this direction, the component of this along this will be acting in which direction? This direction. Have you understood? Clear? So sigma n dAn, if it is taken positive, then what will be the sign of sigma sigma x dAx cos phi? So this is the component which is acting along this. So this is actually sigma x dAx cos phi, which is acting in the opposite direction. So what will be the sign? The sign will be negative. Have you understood? So how we are resolving the force? We are resolving the force along the axis where the sigma n is active, and also we have to resolve the force along another one axis. This is actually tau, right? So your axis system wise, if I see, so this one will be your tau, because you see the sigma n and tau, these two will be perpendicular to each other, isn't it? Sigma n and tau will be perpendicular to each other, and you see the direction of tau we have taken. The direction of tau is in this direction. Is it clear? So this is actually tau dAn, right? Tau dAn. So component wise, when you are resolving, so sigma x dx cos phi you have understood. So a term is coming sigma minus sigma x dx cos phi. Is it clear to everyone? If you have question, doubt, you ask, because all the other components will be resolved like this one. Okay? Now next part is sigma y dAy. So in which direction sigma y dAy is acting? Can anyone tell? Sigma y dAy. Sorry, here I have written wrong. This is sigma y dAy. Okay? So sigma y dAy is acting in which direction? Downward. So sigma y dAy. So sigma y dAy is acting in this direction. If I take a resolution of force of this sigma y dAy along this direction, what will be the value? So if this is phi, so this component gives you cos phi. So what will be the component of sigma y dAy along this? So there will be sigma ay dAy. So there will be a resolution of force for this sigma y dAy. So there will be sigma y dAy, and then there will be sin phi. What will be the direction? The direction will be opposite to the direction of the force of sigma I dA. Have you understood why it is coming opposite? Because you see, just you try to replicate these two. So this is your perpendicular axis, and these two axes are also perpendicular. So this is your original x, original y, and this is your sigma n axis, or the perpendicular axis to the inclined plane, and this is along the plane. So these two will make an angle of 90 degrees. Okay, and these two will make an angle of 90. Is it clear? So second resolution, have you understood? So sigma n dA, then minus sigma x dx cos phi I have explained, then minus sigma y dAy sin phi I have explained. Then what is the next component? What is the next component will come? So sigma x, sigma y we have done. Then we are having tau xy, right? So we are having tau xy and tau yx. So you see, here we have already taken the sign of tau xy and tau yx into consideration, because the sets of tau xy and tau yx we have taken, considering it as the complementary space. So we need not to again replace it with sign. We need not to again replace it with sign. Okay? So that's why later on you see I have given a note also on this. Okay? So you see, if I now resolve this tau x, first let us resolve tau yx. So tau yx is acting along which axis? X axis. So tau yx, if I draw like this, so what is tau yx dAy? This is your tau yx, tau yx dAy. So if I take a component of this force along this, what will be the direction of it? The arrow is in this direction. So the direction of this force along this will be in this direction. So what will be the resolution of force? Tau yx dAy cos phi. So you are getting another one term, tau yx dAy cos phi. And why it is positive you have understood? Because it is the direction, in the same direction as it is of the direction of sigma. Clear? Now the next term. So tau, so what are the things we have completed? We have completed this one. We have completed this one. We have completed this one. What is the other component of force? So it is this one. So tau xy dAx. So along which axis it is acting? Along y-axis. So it is again along y-axis it is acting. So if I erase this now to understand it a little better way. So if I erase this, then along which axis it is acting? So this component of this is acting along this axis. So this is actually your tau xy. What is that? Tau xy dAx, right? Tau xy dAx. So this is along y-axis. So if I take a resolution component along this sigma n, then what will be the value? Tau xy dAx sin phi. If this is phi, then this is 90 minus phi. So if this is 90 minus phi, then component of this along this, and which direction it will act? This will act along the direction of sigma n. So that's why the plus sign is coming. Have you understood? Is it clear? And resolving all these forces along the sigma n axis, what we are getting? We are getting that sum of all the forces along that sigma n axis should be equal to 0. That is what is the equation of static. So we are applying nothing but the equation of static. We are just resolving the forces. Okay? Now next is you see, then the formulation and calculation, everything is algebraic and trigonometric, nothing else. Only after this some concept of mechanics coming, some concept of strength of materials coming. Okay, beyond that, the steps you will follow, those are all simple algebraic and trigonometric steps. Okay, so let's see what is there. So after the resolution of the forces, you have seen earlier we have developed two terms, that dAx equal to dAn cos phi and day is equal to dan sin phi. Because you see in this equation you are having term like dA, you are having term like dAx, you are having term like day. So to remove the area from the equation, you need to bring it to the same area component. Okay, so what I will do, we will replace the value of dAx with dan cos phi, and we will replace the value of day with dan sin phi. Have you understood? Is it clear or not? Okay, so next step if you see what we are doing, sigma n dan, this will be equal to what? I am taking it to the other side, so that is 0. So sigma x dAx cos phi, sigma x dAx cos phi, it is going to the other side, it is becoming positive. Okay, from this equation I am coming here, so sigma n dan will be equal to sigma x dAx cos phi, right? But what is dAx cos phi? What is dAx? You see, dAx equal to dan cos phi. So that's what we are replacing. So dAx value is replaced with dan cos phi, and there is another one cos phi remaining over here. So there will be another one cos phi. Have you understood? Is it clear? Simple algebra, nothing else. Okay. Next step. Next you see, if I take to the other side, if I take this to the other side, sigma y day sin phi. Now what is day? Day is nothing but dan sin phi. So I am replacing sigma y dan sin phi into sin phi. Have you understood? Now you see the other two terms, that is tau xy day cos phi, tau xy dAx sin phi. So they are on this side positive. So if I take it to the other side, it will become negative. And you see, we will not change the sign of, will not make tau yx equal to tau xy, minus of tau xy. Because you see, actually what happens? Actually tau xy is equal to minus of tau y. Why? Because they are complementary shear stresses. They should be in the opposite direction. But when we have assumed for this small body or small rectangular element, in that we have already taken into consideration the sign of tau xy and tau y. That is the way we have put the sign, right? That's why tau yx and tau xy are taken into opposite direction, that is clockwise and counterclockwise. So that's why we will not put again back the sign of tau yx equal to minus tau xy. We will just continue with the same sign. Okay? So that's what we have seen. I have written note here, we have already assumed the sign. So not putting minus over here. We are not putting minus over here. Sometimes confusion comes related to it. Why we are not putting minus? Minus we are not putting because while taking the force, we have already considered the sign of the complementary shear stress in that arrow direction. Clear? Next is, if I now take it to the other side, so tau yx day cos phi, so tau yx, what is day? What is day? Day is nothing but dan sin phi. So it will become minus tau xy dan sin phi into cos phi, and the other term will become minus tau xy dan sin phi cos phi. That should be equal to 0. Unless and until you do practice, then you get confused. Okay? So you can do it. Have you understood what we are doing? So we have resolved the forces along the sigma n axis, and then what we are doing, we are just replacing the area components with the sine and cos component of the area along the sigma n axis, nothing else. Okay. So now after this, it is the trigonometric simplification. Okay, it is very important because trigonometry will come into picture. Because if you when you will be discussing about a concept called Morse circle, then also you will see trigonometry will come into picture. Because finally you will see the state of stress can be described using a circle. Okay, the state of plane stress can be described using the points on the circumference of the circle. Okay, so that is where we will be coming, and these trigonometric expressions are very, very important. So you see, now we are simplifying it. So have you noticed that after replacing the dx and dy, there is a term dA come into picture, and then every term is having dA. So what will happen to dA? So dAn will cancel out, right? dAn will cancel out, correct? So after dAn is getting cancelled out, what you are getting? Sigma n is equal to sigma x cos square phi, sigma x cos square phi plus sigma y sin square phi, minus what will happen to this tau xy should be equal to tau xy, right? Sorry, tau xy should be equal to tau yx. That means we have replaced tau xy or tau yx with tau xy because they are complementary spaces. Okay, so minus of this part you have understood why you are putting instead of tau xy, tau yx, we have put tau xy. Why? Because they are complementary stresses. So complementary stresses are equal and opposite. So equal value we have put. Sign of the oppositeness is being taken already considered into consideration while we have taken the resolution of the forces. So this will bring you minus 2 tau xy sin phi cos. Okay. Now come to resolving into trigonometric part. So there are trigonometric identities if you remember. So there are 3-4 identities to be used. First one is 2 sin phi cos phi. Is that how much? Sin 2 phi, right? And then another one important identity you will get, that is cos 2 phi equal to cos square phi minus sin square phi, and then cos 2 phi. What is cos 2 phi? Cos 2 phi is nothing but cos square phi minus 1 minus cos square phi. Or rather, if you say cos 2 pi is nothing but equal to 2 cos square pi minus 1, or cos square pi will be equal to half of 1 plus cos 2. Okay? So we are bringing the equation or taking the equation in the terms of twice part, not in part. Because you see, there is a term in this equation which is 2 tau xy sin phi cos phi. So this term we are just making it 2 sin phi cos phi, we are replacing it with sin 2. 2 sin phi cos phi, this is being replaced with sin 2. Okay? Now we want to bring this cos square phi, sin square phi, this also into the term of 2 phi. So how do I do it? So I use this trigonometric identities. Okay? So cos square phi is how much? Cos square phi is half of 1 plus cos 2 phi, and sin square phi is nothing but half of 1 minus cos 2 phi. So I will replace these into equation. So then sigma n equal to sigma x. Cos square phi I am replacing with half of 1 into cos 2 phi, and sin square phi I am replacing with half of 1 minus cos 2 phi minus tau xy sin. So what will be the value of sigma n then? So if I simplify it, so sigma x, so half of sigma x will come, half of sigma x, then sigma x into cos 2 phi, and then there will be sigma y minus cos 2 phi, and there will be sigma y into sigma y by 2. So you see, sigma x by 2, there will be a sigma x by 2 term. So there will be a sigma x by 2. Have you understood? sigma x by 2 term will come from here, sigma y by 2 term will come from here. So I have taken half as common, and then sigma x plus sigma y. Then you see, this will give you half of sigma x cos 2 pi. This will give half of sigma x cos 2 pi, and this will give, so one term will get half of sigma x cos 2 pi. Another one term will get minus half of sigma y cos 2 pi. Have you understood? So if I take half sig cos 2 pi common, so that's what I have done. Half of cos 2 pi I have taken common, and you are getting an equation. You are getting 2 terms sigma x minus sigma y, and this will remain same minus tau x by sin. Have you understood? So now you see, we have started with 5. We have landed up with an equation which is in terms of 2. Okay, and this is what actually is the equation of normal space along an inclined plane, which is making an angle phi in the anti-clockwise direction with the x plane. Is it clear? So this equation you need to remember, and this is the anywhere, wherever you will be applying the equation of plane stress condition, then you will have to remember this equation and apply. And you see, in this equation everything is included. Sigma x is there, sigma y is there, tau xy is there. So all the stress components are included in this equation. So depending on the different cases you have, like the case 1, case 2, case 3, in the previous class I have discussed. One is the case 1 was for the longitudinal stress, case 2 was for a cylindrical element or a cylinder which is under hydrostatic pressure, let's say. Case 3, a beam under torsion or a beam subjected to vertical load. Okay, so all these cases, if you generalize, this is the generalized equation of stress along the normal of the inclined plane, and the normal stress will be defined with this half of sigma x plus sigma y plus half of sigma x minus sigma y cos 2 pi minus tau x by sin 2 pi. Have you understood? Is it clear? So this is the equation of normal stress. Now also along the inclined plane, you will see there will be an existence of shear stress. So what will be the equation of shear stress? Because we are concerned about two stresses, right? Normal stress and shear stress. So equation of normal stress we have found out. Now we will have to find out the equation of shear stress. So how do I do it? Again the same concept I will apply. Okay? So I will resolve the forces. Which forces? Which forces I will resolve? I will resolve these forces. I will resolve this sigma y dy. I will resolve sigma x dx. I will resolve tau x y dx. I will resolve tau y x dy. Along what? Along this inclined plane. Along this inclined plane. Because my shear stress is acting along the inclined plane. So resolution of force will happen along this axis. Have you understood? Resolution of force will happen along this axis. So you see, if this angle is phi, how much is this angle? If this angle is phi, how much is this angle? 90 minus phi. Very good. Then what is this angle? It will be 5, because you see this and this one and this one, these are at 90 degree. So this is 90 minus 5, so this will be 90 minus 90 minus 5, 90 cancel out. So this will be 5, right? And this will be how much? This will be again 90 minus 5. So please, while resolution of the forces, don't get confused. You will have to use this convention of the angle. Okay? And now you resolve the forces along the tau axis, or let's say along the inclined plane. Okay? Along the inclined plane. So what will come? So where does the tau am? Where does your So let me just erase these things so that will be more clear. So let's say this is your sigma. What is this? Sigma n dAn, right? And what is this? What is this? This is actually tau dAn. That's all. Right? Now, what are the forces we will be resolving? Along which plane we are resolving? We are resolving the forces along this plane, right? Along this plane. So this is your tau A dN. It is acting in which direction? This direction, right? It is acting towards the origin, right? So we have taken, you see, we have taken this as positive. Tau A dN. Towards the origin, you have taken positive. Okay? You can take negative also. According to your convenience, you can take. Okay? I have taken it as positive. Okay? Now, you tell me, if I resolve the force sigma y dAy, where it is acting? Tell me. Sigma y dAy, where it is acting? Sigma y dAy. It is acting in this direction. Correctly correct. So sigma y dAy, this is acting downward direction. So if I resolve this force along this, so what will be the angle? This angle is phi. So it will be positive, right? Resolution will be positive. So it will be sigma y dAy positive. What will be the sign? Positive, because we are saying towards the origin, that sign is positive. So that's why you see here I have taken the sign as positive. Sigma y dAy positive. Have you understood? Clear? Next what I will resolve? Next sigma x dAx, right? So if I resolve sigma x dAx, in which direction sigma x dAx is acting? Follow? So sigma x dAx is acting in this direction. Have you understood? Sigma x dx is acting along this direction. So if I shift it, so in which direction it is acting? Sigma x dAx is acting in this direction, isn't it? So sigma x dAx is acting in this direction, right? In this direction. Now if I resolve this force along this axis, what will be the resolution component? Sigma x dAx. So if this is phi, this is 90 minus phi, right? So what will be the component of this? Sigma x dAx sin phi. In which direction? Direction will be in this way. Is it positive or negative? Negative. Why? Because we have taken direction towards origin as first. So that's why the sign came here minus sigma y dAx. Sorry. Minus sigma x dAx sin phi. Have you understood why sin phi is coming? Because the component of this along this is d sigma x dAx cos 90 minus phi, and cos 90 minus phi is nothing but sin phi. Have you understood? Is it clear? Please go back and practice it once. Okay? Then it will be very clear to you. And this resolution of forces are important. Why I am saying? Because when you take up the problems of two-dimensional stress condition, you need to understand in which direction the forces are acting. And you see, these are not at all difficult. Because what you are doing, only you are resolving the forces along two different axes. Nothing else you are doing. And what is the third component? Third component is tau xy dxy dAx and tau yx dAy. So if you resolve those components as per the convention I have said, then what will be the resolution component? So you see tau yx dAy, it is acting in this direction. So if it is acting in this direction, and if I resolve this along this axis, what will be the direction of it? It will be positive. So that's why you see tau yx dAy sin phi. It is the positive direction. So this is acting tau yx dAy, right? So this is acting along this axis, correct? So if I resolve it in this side, Then what will be this? Tau yx bay cos 90 minus pi, which is nothing but sin. So it is coming with a positive. Tau yx bay sin. Okay? And the fourth component, if you resolve, you will get a negative sign. Fourth component, if you resolve, you will get a negative sign. Okay, I leave it to you to guide. Okay? And if you have any question or any confusion, get back in the next class. Okay? So with this concept, you have got an equation of tau. So we have developed an equation for sigma n. Now we have got an equation for tau. Right? So what you have to do? See, in this handout, I have done each and every step for your understanding. In books, you will not get it like this. There will be directly step jump, and they will write first equation and then they will write this equation. But that is very confusing to understand. So I have given each and every step in this handout. Okay, even the trigonometric identity, how to replace it, that also I have explained. Okay, for your clear understanding. Okay. Now if you replace this terms of day and dax. Okay, so day, dax, if you replace, in which term you will replace this thing? In terms of dax. We have understood it. So dax equal to how much? Dan cos pi and day equal to those similar terms you will replace. So again I have replaced exactly the same way we have done it. Again we have replaced it for the next one. Okay, and you will see every component will have a term dan. Okay, so then the dan will vanish from there. Correct? So once you vanish the term dan, what you will get? You will get equation in this way. Tau is equal to sigma x. You see sigma x, you have a sin phi cos phi. So you get sigma x sin phi cos phi. Minus, you are having a sigma y term. So sigma y also comes with sin phi cos phi. Okay? And then you are having tau xy and minus tau xy. Please notice over here. In the previous case, what you had? You had tau xy and another one tau xy. Both are having same kind of sign. So minus 2 tau xy. Here you see one tau xy has come with positive sign, one tau xy has come with negative sign after the resolution of the case. So here what you have to do? You will have to take tau xy common. Okay? So you take tau xy common. And that will give you cos square phi minus sin square phi. You take tau xy common, you get cos square phi minus sin square phi. And again, what I have told you, the equations will be taken into the terms of twice pi. Correct? So again, you have to use trigonometric identity. So now, to make this sin phi cos phi in terms of 2 pi, what I have to do? I have to divide this by half and multiply this with 2. Correct? If I divide by sigma x by 2 and then multiply 2 sin phi cos phi, what it will become? This will become sin 2. Correct? 2 sin phi cos phi is how much? Sin 2. So that's why half I have taken 2 sin phi cos phi, right? So I will get sin 2. Here again, if I do half multiply by 2, I will get sin 2. So what I will get? I will get a term sigma x by 2. And I will get a term sigma y by 2, both will be multiplied by a term sin 2. Correct? So if I take sin 2 pi common, then what are the terms remaining? Half of sigma x minus half of sigma. So half I have taken out. So equation becomes now equal to half of sigma x minus sigma y in this way. Right? And what will happen to this tau xy cos square phi minus sin square phi? So see the trigonometric identity. So what is cos square phi minus sin square phi? So if you see cos square phi minus sin square phi, that becomes equal to cos from the trigonometry. So this cos square phi minus sin square phi being placed as cos square. So see the equation this part. Tau is equal to half of sigma x minus sigma y plus sigma x minus sigma y sin 2 pi plus tau xy cos. So what you have achieved through this resolution of forces? We have achieved the final value for the forces, final value of the stresses in an inclined plane, which is making an angle phi with the x plane, right? Along the normal axis and along the inclined axis. Okay? And you see the similarity of this equation. It's very simple to remember also. Check the above equation. Sigma n का equation देखिए क्या लिखा है? Half of sigma x plus sigma y. Half of sigma x plus sigma y. Right? Next term क्या है? Half of sigma x minus sigma y. उसके बाद multiplication क्या है? Cos 2 phi. Cos 2 phi. उसके बाद क्या है? Minus tau xy sin 2 phi. Okay? है ना? Now similarity देखो. नीचे वाला इक्वेशन को देखो. नीचे वाला इक्वेशन में ये टर्म नहीं है. हाफ ऑफ सिग्मा एक्स सिग्मा वाई टर्म नहीं है. सिर्फ चेंज क्या हो गया? हाफ ऑफ सिग्मा एक्स माइनस सिग्मा वाई cos 2 phi has become sin 2 phi. Check it. Cos 2 phi has become sin 2 phi. Right? And next part को देखो. वहां पे नेगेटिव साइन था. माइनस tau xy sin 2 phi था. यहाँ पे पॉजिटिव कर दो. tau xy cos 2 phi. So if you remember one equation, कर वाला सिग्मा इन रिमेंबर करते और एक सिमिलरिटी सोचते हो. So next equation will automatically. You understood? Okay? So this is what is the very important thing to understand in case of two-dimensional plane stress problem. I think time is over. Okay? So I stop here. In the next class, we will discuss in more detail about the special cases of this, and we will see how these things are related and what is actually principal stress, what is principal plane. These kind of terms we try to understand, and then we get into the concept of mode system. Okay? So I stop here today, and next class will be on Monday, right? So let's discuss it.